I have this professor who was very enthusiastic, and he always talk about these things, the applications of physics, why the polycopy machines operate, a bunch of physics there. He talked about the nuclear energy operation. This kind of thing, and that made me fall in love with it. And then after I showed that special relativity, the time is relative, it's not absolute, and I said, no, it's impossible, that's fiction. So when I saw these things, which I believe are fiction and are reality, I said, I have to understand this. I have to go deeper. And then I started like a hobby, no? And then after this hobby became serious, because after I went to master and PhD in physics. Why gravity? Because when I was in master, I wanted to understand general relativity. There was a big expert in the field, Professor Ivan Arraut. He's German. He was my supervisor, and I learned the techniques of research from him. Then, let's say after I was just in love with physics, and I liked to solve impossible problems. Because in physics we are doing the whole time that we are trying to solve something that nobody else has solved. I think we can tell you that. Let's say you want to solve something that nobody else has done, and you want to say, hey, I solved this, it's mine, it's published in my name. This is a way to, of course, it sounds very arrogant, but we all want to make some name in history, of course, it's human nature. But I mean, the fact, I think science is a combination of humble and arrogance. The fact that you say, I want to solve this that nobody else has solved, that's arrogant. But we have to be arrogant. We don't solve it. And at the same time, we are humble enough to recognize that we don't know everything. There are things we don't know. There are some details we don't understand because we are specialized in certain fields. There are things in physics, topological material, idea, etc. But I mean, in summary, what made me fall in love in physics was a very enthusiastic professor, very good when I was in the Bachelor of Engineering, and then I started to pursue, to chase more and become more ambitious. I studied quantum mechanics for myself, and I validated it with an example. And for that, you know how dedicated you have to be for that. Because one thing is that you go to a class and you receive it, and then one semester, taking one exam, they tell, prepare this in 1 month, and come here in 1 month and do the exam. Then you have to become like crazy every day. I almost died, I think, and then after taking exams, so that's love. That's love for the science, love for. Every day you wake up thinking, today I will do something different. Another detail is that in science, and this your friend can tell you, is that every day is different. It's not routinary. They say when you are in science, there is no routine. Because every day you see something new, every day you discover something new, every day is different. And this is what differentiates standard jobs, for example, from research jobs. With all the respect of yours. That's why we are never bored. It's not boring, actually it's very enjoyable. Doing science is the most enjoyable thing you can do. If you fall in love with that, but you have to first understand. From understanding it, you have to be passionate and dedicated. But once you understand it, you say, oh, this is the best thing I have done in my life. And then you start to play around and try to discover things and so on. So I don't know if I hope this was on the question. It's very important to fall in love with what you do every day. And it's a process. It's not that you one day wake up and they say, I know everything. Every day, little by little, slowly, you are learning new things, and in a few years or so, depending on your dedication, you realize, hey, now I know many things. If I knew myself 10 years ago, I didn't know anything. Now I know so many things. But still keep ambitious. Every day try to learn something new. Every day. So that's the secret of the science.
Thank you very much. Much appreciated.
Any other question? I think you wanted to say something. I remember. Yeah, okay, you can take this one. I take it over.
Thank you. I would like to ask, as scientist, how do you deal with uncertainty? How do you think of a fluid?
Uncertainty, you mean?
Where if you could give us any specific example, like how do you deal with uncertainty?
You mean you sent the principle I explained?
Or any other applications?
Well,
Or how do you think of the, you study with the quantum mechanics, and probably you have some different ideas to see the world.
Yeah, what happened is that this is a question because, for example, uncertainty is not a big concept. It's not a concept of quantum mechanics. It was before there, no? But it's different to the uncertainty principle of quantum mechanics is different to the uncertainty we see in measurements. When you measure, I don't know, I measure this table here. I say 45 centimeters plus minus, I don't know, 3 millimeters. That's an uncertainty. That's an uncertainty. I don't know if it's 45 millimeters minus 3 millimeters. No, sorry, 45 centimeters minus 3 millimeters or 45 centimeters plus 3 millimeters. That's uncertainty. You have a range of values that you don't know. But this can be arranged if you have a more accurate tool for measuring this. You can have a more sensitive instrument and you can measure it better. Quantum mechanics is different because this is fundamental. It's at the heart of the theory. It means you cannot avoid that uncertainty. Uncertainty in quantum mechanics is something you cannot avoid. This one you can avoid. You bring a better instrument and it you sharply 45 point something. That's it, to eliminate uncertainty. But in quantum mechanics you cannot eliminate uncertainty. And I will give you an example. I am moving here, I am a particle, I am moving here with some velocity. But you don't know where I am because I can be anywhere, you can't see me. You say, where is Ivan? He's anywhere in the room. Then you try to locate me. For locating me, you have to throw me something. You throw me a glass. That glass is the light. The glass hit me. You destroy my velocity. So now you don't know my velocity, but you know my position. This is fundamental in quantum mechanics. I said, you know one variable or the other. And something important is in quantum mechanics, you cannot know all the variables of the system. You can only know, you have to decide, I work in momentum space or position space. I know the angular momentum or the angle. So there are some set of variables which I can define simultaneously, but there is another set of variables I cannot know, or vice versa. So, or I can know partially the position, for example, I can know partially the position of Ivan. I don't know where it's going. It has to be between these two columns here. And you can know partially my momentum. But the more you know my position, the less you know my momentum. And vice versa. Momentum is mass times velocity, essentially. So you will know less my velocity, the more you know my position. I will call it velocity, but it's momentum, the correct values. Then, I don't know if that's responding to your question, but in quantum mechanics, uncertainty is more fundamental. You cannot avoid it. It's at the root of the theory, and all the formalism of quantum mechanics is done with this principle. And that's the Copenhagen interpretation of quantum mechanics. Many people appear trying to do alternative interpretations of quantum mechanics, but to be honest, those are just interpretations and they don't have any value because the experiments, they have to rule out the Copenhagen interpretation. That's why we use the Copenhagen. Copenhagen means because it was born there, is the interpretation that says that the particles are wave, when an electron crosses to a slit, if you cross the two simultaneously, it behaves that way, it interfere here. All these kind of things I explained here is called Copenhagen interpretation of quantum mechanics. It's the one which followed Heisenberg, Schrödinger, Dirac, all these guys follow this formulation. But in summary, the uncertainty in quantum mechanics is different to the uncertainty you see in the laboratory when you are measuring things. There's some uncertainty involved, but that uncertainty you can always avoid with more accurate instruments. In quantum mechanics, you cannot avoid that uncertainty. You cannot know where the electron. For example, double slit experiment. Let me go back to one slide for you to have an idea of what I'm talking about. When the electron is crossing the two slits, look at this here. When I throw one electron, and the electron has a wavelength associated with it longer than the separation of the slits, usually. The electron crosses both the slits simultaneously. That's the uncertainty position of the electron. I don't know where the electron is here, or is in between. I don't know, but it crosses both at the same time. Uncertainty position is this distance when it crosses. But if I try, okay, I will try to measure in which I put an instrument here. I put some small instrument. But that instrument, for knowing if the electron crosses it or not, it has to collide the electron. Then it collides the electron, you destroy this pattern immediately. The pattern weight is awake immediately. So because of the uncertainty principle, you try to know location, you lost the interference pattern, which is related to the momentum. So intrinsically, quantum mechanics, Einstein killed himself many times trying to destroy quantum mechanics. He didn't like this. Einstein was a deterministic guy. Don't misunderstand. Einstein was expert in statistics. Actually, his biggest expertise is Brownian motion statistical mechanics. But by the time the physicists were not so specialized, they just do everything. So, but he didn't like the fact that you couldn't know momentum and position simultaneously. That's not consistent with what he believed in reality. So he tried to create imaginary experiments where and always just bored the others, destroy his arguments. They said, no, because he always lost. I mean, that's a lost battle of Einstein. Einstein could never defeat quantum mechanics. He tried with himself, and everybody who has tried always failed. So, this is uncertainty principle. Myself, when I studied physics, when I started master, the first problem I said, I want this problem. I want to solve the weakest link. No, it's impossible. At the end, you give up and say, no, it's a problem which nobody can solve. As soon as you try to measure which slit cross, you destroy the interference pattern consistent with wave. Of course, because it became as a particle. Once you collide, you locate, it's a particle. But you lose trace of the momentum. That's the uncertainty principle. More fundamental than the uncertainty you see in it. Any other question? There's one there.
Hello, Professor. I actually have two questions. The first one, to continue the uncertainty question. You already explained the uncertainty in measurements, but I want to know, I mean, it's more like a philosophy question. Like, for people who started in quantum mechanics, well, you have different view about uncertainty in daily lives. Like, there are incident happens in daily lives. But, well, the quantum mechanics give you different view to think it.
Uncertainty what, sorry?
Like uncertainty in life. There are some incidents, right?
Okay, that's a good question. Actually, this physicist called Feynman. I met him in Tsukuba, Ibaraki, Japan, because I spent 1 year in Tsukuba. It's a research area full of research institutes. He's an Israeli physicist, quite recognized. Most many physicists are recognized also. Then the point is, he was presenting a story, and the uncertainty you mentioned is curious because imagine that you are sitting here, or some of you are here, and then what happened? I can decide to go out from this door, or I can decide to go there, or I say, oh, I will go to the supermarket, or I go to my hotel first, or there are guys who have done these theories of parallel universes. They call it parallel universe, where there's a universe where you go to the supermarket first, but there's another where you decide to go to the